In the exam, all you were given was the text. You weren't given the image. The whole idea is that you would be able to sort of draw that based upon that question there. And again, you would just pull off your formula from the formula sheet. So we have, in terms of this formula here, we have PCR. We also were given the length in the question. And we can work out the area, the second moment of area. We don't know what E is. If you find that you haven't got your value of E, then it's highly likely that you're going to have to be messing around with your stress and strain values to try and find out what E is. 10 squared, take away the inside, is 6 squared. That equals 64 pi. So again, that's just using your area is pi r squared, and it's the outer diameter, take away the inner diameter. From Hooke's law, we got stress over strain. Our stress is force over area. Our force is 450 kilograms multiplied by 9.81 to put it into newtons, divided by our area. So we've now got a formula for our stress and for our strain. Change in length over original length, and we're told that it was 1 millimeter extension over a 3 meter length. So if we put both of these into this formula, so we don't have our A value to put into the Euler formula, so we're using our stress and strain to work that out. So we've got our Hooke's law. E is stress over strain. From our stress, we've got our force. We've been given the force in kilograms, so that's your mass times acceleration. So 450 times by 9.81. Because I've been in industry for such a long time, a lot of times we just use that as a value of 10. You use 9.81. If you use the exact value of 9.81, whatever it is, then you'll get like a slightly different answer. I'm okay with that. In terms of the area, I've left it in its purest form of 64 times by pi. Personally, I multiply it out by 3.142, and I stop there. But I'm just trying to look like I have some mathematical ability. When you've got stress divided by strain, it's the same as stress times by a flip on the strain. So we just got that times by that, and when you multiply everything out, you should kind of get 658,000 newtons per millimeter squared. So in terms of our Euler, we've got P, we've got E, we know our length. Now we've got to look at I. Do you have the formula tables in the back of this handout, or is it just the other one? Yep, so we've got a circle. We've got the I value is pi d to the 4 over 64. We'll get there. Because L is 3 meters and it's pinned either side, L equals LE, so it's 3. So I of a circle, pi d to the 4 over 64. So for a tube, which is what we have the outside d to the 4, take away the inside 12 to the 4. So So our PCR is pi squared times by our E value times by our I value divided by, and again, because it's pinned either side, our effective length equals our length. The length is 3 meters. We've got everything in millimeters. So it's 3,000 millimeters. And that's 493 newtons.